Hi there, Science 10. So today we're going to take a bit of a very brief detour from looking at energy because we're going to start looking at ecosystems. Later on, though, I'm going to tie in this whole ecosystem concept with energy. The reason I'm starting this today or doing this today is because I'd like you guys to get start fairly soon on your unit project or one of your unit projects here, which is the ecosystem Phototour. Basically, the purpose of this is to get you guys outside and appreciating your local ecosystems and looking at them with more of a kind of the eye of a life scientist. So first of all, what's an ecosystem? Simply put, there's a number of different ways of defining it, but I think of it as for any location in the biosphere, in our living sphere, it's the combination of the physical properties of the environment, the soil, the climate, the rainfall, along with the living components, the organisms that live there. What's the vegetation? What are the animals that live in that environment? And then how those parts interact with each other. How does the weather, how does, say, the snowfall affect the plant cover? How does the wind affect how long the trees live, which is going to affect the structure of the forest, and so on. These are all questions we can ask about ecosystems. Now, often ecosystems are named based on where you find them. You could talk about the Lake Catherine ecosystem, which is kind of self-explanatory about what it is, although in terms of what actually goes on there with the organisms, that becomes a different question. So you could name ecosystems based on where they are, but in BC we have a bit of a different system, a very interesting and useful system. Some of you might go on to work in forestry. You might want to become familiar with this. It's called the Biogeoclimatic zone system. And BC is very interesting for looking at the variety of different ecosystems that exist here because we've got so many of them. So what does that biogeoclimatic part mean, and why is BC so interesting for that? I'm going to zero in on that word up here. Right. Sorry about this. Right there. It's a three-part word, biogeoclimatic. If you see bio before a word, that tells you you're dealing with something related to life or living things. Geo, think rock. Think about, and of course what is determined by the rock. Think about the soil, the properties of the soil. That's partly to do with the rock that's there. And then climatic, that's the long-term patterns in weather. And we're going to get a little bit more into climate in some later lessons here. So those three things determine the kind of other organisms that can survive in a place. In BC, our climate and the rock differ hugely from one part of the province to another. This is to do with differences in elevation, differences in the bedrock, which is partly determined by the fact that this whole province just about used to be covered in glaciers not so long ago. And especially how far we are from the ocean. Let's look at a rough map of BC that I drew up here. So here's the province that we all live in. Now, I know it's not perfect of a map, but we're going to look at some better ones there. That's what I'm trying to do. So we have our ocean right here, the Pacific Ocean, Haida Gwaii, Vancouver Island. We're around over here. We're in the Skeena River watershed. And of course, notice this other thing about BC is it's got the coast, and then it's got the Coast Range Mountains. And then it's got this central plateau, this large flat area that's kind of a higher altitude. And then you've got the Rocky Mountains again. So we got a huge variety of different kind of terrains that living things have to contend with here. And that also affects the climate. Because what happens is when there is precipitation, much of that rain is coming from the ocean. The water that provides that is coming from the ocean. So weather systems are carried from the ocean by wind currents over the province, As that wet air rises, it encounters cold air. The decrease in temperature of the wet air causes precipitation. So here, on this western side of the mountains right here, you're going to get a lot of rain. Here in the interior, a lot of that water has already been lost. If you go, say, to the Princeton, I was there once. It's really interesting. It's just east of Vancouver, but if you compare over this short space of short distance from the ocean, it's a really dry town versus, say, really wet. Like you go to Chilliwack, super wet in Chilliwack. You go over the mountains, and it's very dry in Princeton because by the time the rain systems have dumped their rain in the mountains, they don't have any left over to rain in these interior areas. Here around Smithers is a little different because, of course, we're in this kind of a corridor. Weather systems can work their way up the Skeena River Valley into the Bulkley Valley, and so we still get some of that precipitation coming off the ocean. And then, obviously, once you're reaching the Rockies, water can be picked up from freshwater ecosystems in the center of the province, and then the weather systems continue further west and dump their water in the Rocky Mountains. Not as much precipitation there, but still plenty of it. And so with all this variety of different kinds of terrain, soil, climate, especially rainfall, temperature, because of course it's subarctic conditions when you're in the far north of the province, and it's desert conditions because it can be very hot in the south of the province. We have the variety of different temperatures in BC. We have a huge variety of different kinds of living things that can exist in that environment. For that, to describe that, there's a system called the Biogeoclimatic zone system. As I've described to you, I just told you about it. What I do want to tell you is this, that around Smithers, we're in a very special location. We're not so far from the ocean. We have some, but we're also not too far from the interior, right? We're kind of on the border between them, and we have mountains surrounding this town. So we have many different biogeoclimatic zones that exist within a very short distance of Smithers. What I'm going to do just now is I'm going to shut this video off, and I'm going to do a bit of a screen share to help clarify that a little bit. Here we go. Okay, so we'll get going here. What you can see right here is what I was able to call up from a Google Maps search. So what we see here is we've got Smithers. This is Lake Cathlin. I guess Smithers is more down, located down here. We've got Lake Cathlin and the airport. Of course, if you look outside, you know you're going to see Hudson's Bay Mountain right there. And also, as you can see, it's surrounded by this ring of very deep green, which is forest, and we've got the ski hill right here. The valley floor is very different. If we had made this video based on photos from, say, 200 years ago, that would have been a lot of deeper green right there as well, because the valley floor used to be a lot more forested. But it probably would have been a different shade of green, because the tree species really are very different in one place relative to another. If we look over in this direction, we see we've got the Babines, Babine Mountain Provincial Park. These are the mountains you see when you look further east from here. So here in Smithers, we're basically between two sets of mountains. We're between the Babines and Hudson Bay, and but if we even consider a bit bigger scale, here we are located with the plateau of the central part of the province to the east and to the west. As we go through Terrace, Prince George, we're then getting to the ocean. Smithers is kind of at a crossroads of a lot of different ecosystems. All right, let's go back. There we are again in Smithers. So the next thing I wanted to kind of show you as well is this. This is a map here of the biogeoclimatic zones of BC. In fact, this is the one I wanted to show you. This is accessible from, this website here, my bad, whatever. We'll get to that in a sec. This is accessible through the Forestry of British Columbia website. What we see right here, pay close attention to what you see here. These are different biogeoclimatic zones. Notice that BC has got this crazy patchwork of different kinds of ecosystems and that's determined by the difference in latitude. That is to say, this here is much further north, so this is a very cold part of the province. Also, it's determined by these mountain chains that you see right here. These are the Rockies, and these are the Coast Range. And of course, that here we have the ocean, which carries water, carries weather patterns off the Pacific Ocean. And we have rain and the rainforest along this stretch of the outer coast. But around here in Smithers, Smithers is right there. There's maps that are at a similar scale. There's a lot going on at once. We've got a kind of a joining of different environments. Also, I'd like you to notice this. These different zones are named based on the dominant tree. So for example, this is the boreal white and black spruce zone. Look where it is. It's in the far north, especially the northeastern corner of the province. It's really cold, and the trees are very small. The one that is of interest to us would be this one here. There's two that are of interest to us. If you're watching this video from Smithers, you're sitting probably in the subboreal spruce zone. You can see it's kind of taking up mostly the center part of the province, although just east of the Alaska Panhandle, we've got some patches of it there too. Here's another one, though, that kind of borders with the subboreal spruce zone. That's the Engelmann spruce subalpine fir zone. Notice this. Both of them are named based on the tree species you find there. Specifically, not just any species, but what are called the dominant species, the ones that are the most common species when you leave the forest to just grow on its own, right? If you cut down the forest in the valley floor here, what comes up in pasture areas, those of you who live out of town, you see lots of aspen, right, and lots of poplar. But if you leave that forest sitting for, say, 200 years, it's going to be your spruce tree that takes over. Just like when you're on the ski hill in the Engelmann spruce subalpine fir zone, that's what you're seeing. You're seeing a lot of subalpine fir and some Engelmann spruce as well. The other zone that is between us and the ski hill forest, some of you maybe do cross-country skiing, or maybe you've been to Twin Falls. If you've done that, you've seen this zone right here, which is the interior cedar hemlock zone. Around Smithers, we've got these three zones, again, named based on the dominant tree. Cedar and hemlock are dominant trees in that area. Now, our ICH, our interior cedar hemlock, is very different from around Nelson. If you've ever been to that part of the province, you see a lot more cedar down there. Here, we don't have much cedar, but we do have lots of hemlock in that zone. Here, I'm going to show you something here. Each of these, if you would like to visit this site, highly recommended, right there. You can find out information about that biogeoclimatic zone, which is very useful for your project write-up. Let's look at that one for that brochure for the subboreal spruce zone where you're located right now. Look at this. The ecology of the subboreal spruce zone gives all kinds of information about where it's found, what's the climate, what are the ecosystems. This is a very useful resource for you when you're doing your project. But the last thing I want to show you is this. I was interested as well in the biogeoclimatic zones and getting a bit more detail about this area. And if you look at this website right here I'm highlighting, you could write that down if you want, or do a search for Bulkley Valley biogeoclimatic zones. Here's what I found. I found this map right here. When I click on that, SRMP Biogeoclimatic Zones map. This is useful because it gives you a much better close-up of what's going on around Smithers. The map takes a while to load, but here's the this is the legend for it. So let's zero in a little bit, go down to, I don't know, 400%. There we go. Again, it takes a while to load, going across to the legend. Sorry about this. And okay, there it is. Okay, here are our biogeoclimatic zones. We have AT, which actually means alpine tundra. That's basically saying, hey, there's no trees there, so we can't name it after a tree. These here, the light purple and different shades of purple, these are all Engelmann spruce subalpine fir. If you go downhill skiing, you've been in this biogeoclimatic zone around Smithers. Don't worry about the lowercase letters. There's different shades. That just means like different versions of the same biogeoclimatic zone. Where you're listening to this or watching this video, you're in the SBS, probably. That's the subboreal spruce zone. Town of Smithers is located in the SBS. And here we have also the pale green and the darker green is interior cedar hemlock. And then we have water and glaciers. Let's look at how that falls out when we're looking at this map of the area. So I'm going to zoom out a little bit. There we go. In fact, let's compare this map here. I'm going to go a little bit closer, say 75%. Perfect. There's Morristown. That's not what I wanted to do. Try that again. Here we are in Smithers. This kind of pale purple color, bluish purple, this is all subboreal spruce zone. This darker bluish one here is also subboreal spruce zone. They're just a different version of the subboreal spruce zone. Now that being said, if you're in this area, just outside Smithers, for example, like around here by the airport, you're not necessarily going to see spruce trees everywhere. They are there, but it's not been allowed to sit there. The forest has been cut down and it's an open field or it's poplars, but it's still in that subboreal spruce zone, even though it's been modified by people. Let's compare that with this over here. I'm going to zoom in a bit on this. And there, Lake Cathlin, Seymour Lake, and go to that map again. Here. So you can probably start to see some of the connection. Lake Cathlin, Seymour Lake, Tye Lake, all subboreal spruce zone, as you see here on this map, and it pretty much overlaps what you have that happens to be largely modified by people. Let's go back here. Engelmann spruce subalpine fir, that's your ski hill, right? There's your ski hill here. But what about this belt right here, this very dark green belt? Well, that is the ICH. That's interior cedar hemlock. For the life of me, I've had a very difficult time finding cedar there. There's not a whole lot of it, but there's lots of hemlock trees when you visit that area. I'm going to do some site visits later. I'm going to show you guys what these different trees look like. But it's not very far. In fact, here we are at the school right here by the little arrow. I only need to walk for about 10 minutes to change biogeoclimatic zones. In fact, if you walk to the ski out and walk up Hudson Bay Mountain, you will start it in the SBS and get into the interior cedar hemlock, and you go up that whole ski out and you get to the Engelmann spruce zone, and then by the time, if you spent a really long day, you'll be in the alpine tundra. 4 different biogeoclimatic zones, which is very interesting because if you look at, say, let's say you are right, I don't know, here around Fort Nelson. If you're in Fort Nelson to get to another biogeoclimatic zones, you got to travel for 100 kilometers. Here, it's walking distance. This is because we've got all this crazy topography around Smithers. We've got this valley bottom, and then right around us, we've got these mountains, and they catch the weather, and they have, as a result of that, they have different tree species that live there, and we're in different biogeoclimatic zones. That's what I wanted to show you in terms of online resources. The Forestry British Columbia site has good online resources for your photo tour. And also this site right here has this map. So for example, when you're doing your biogeoclimatic zone project, you might want to have this map open so you can find out where you did your project. Let's say, for example, you live out of town. I don't know, maybe you live near Canyon Creek or something like that. Well, then you're in the subboreal spruce zone. Or maybe, I don't know, maybe you are up on the Hudson Bay Mountain ski road. At that point, you're probably in the interior cedar hemlock zone, and so on. You can use this map to figure out which zone you're in. Or maybe you want to do something different. Maybe you want to not have it be your backyard. Maybe you want to take a day trip and go up to the top of the mountain and have some fun in the snow. Then you'll be in the alpine tundra zone. Your project, your Phototour project, will be about whichever zone you choose to write about. And you just have to go there, take photos according to the directions, and incorporate those into your project. I really strongly suggest that you use the exemplars a little bit. I'm going to cap off this lesson by making a couple of site visits now and showing you guys some of what I mean by these different zones. Hi there, Science 10. So here we are outside. This is Chicken Creek watershed, or I guess ravine that I'm along just now. You've all been here. We're quite close to the school, but despite that fact, we're in a pretty wild spot. This is an ecosystem which is not so terribly different from what originally existed at this site. Being along Chicken Creek, if you look at the map, as I showed you online, we're in the subboreal spruce zone, and this is these are the sorts of trees, these are the sorts of an ecosystem as you expect to find in this environment. Remember, for your project, I'm looking for photos. I'm looking for a photo of the whole landscape. I'm looking also for photos that are kind of the medium distance that will show individual trees, and then some close-up photos with what your best guess is or understanding about what you're seeing in the photos. I'm looking for an account from you of what kind of human activity there is at the site, and then some different kinds of organisms that live there. This site here, Chicken Creek, is exactly the kind of place you could use this for your project. Although if you live even out at the edge of town, like by some pasture or something, that would be fine too. If you want to go up on to Twin Falls, there's lots of options here in this area for interesting ecosystems you can have as the focus for your project. For this, the reason I'm out here is partly I just want to show you a little bit about the kinds of organisms that you can expect to be seeing if you were to go here. If you look behind me, there, that's an example of what's called a hybrid white Engelmann spruce. That's the kind of spruce tree that this ecosystem is named after. Subboreal spruce zone. It's named after that kind of spruce tree. Reason being, if you were to leave this forest here standing, didn't disturb it for about 200 years, this would become a spruce forest. It's the climax tree that comes from this environment. Of course, spruce trees are very important for forestry, and they're very important for the overall ecosystem structure and the organisms that can live here. But of course, this is not spruce trees alone. I'm just gonna rotate this camera a little bit. So now you're looking behind, and so right here, that's an alder tree, probably a mountain alder, although I'm not totally sure. Alders and other trees that are deciduous are really important in ecosystems like this because chemically the properties of their leaves are different. They're much more tender. If you're an insect, you don't want to eat spruce needles. You'd much rather eat the leaf from an alder tree. So they're very important for the insects, which means they're also very important for the birds. And there's lots of birds that come here only in the spring and summer to eat those insects from the trees. So that's an example of one kind of organisms that you can find here in different tree species. It's kind of hard to photograph the wildlife, the birds, but one thing it's really easy to do is to get a close-up of some of the other vegetation that lives at this site. So I'm going to walk the camera around a little bit and tell you a bit about what we see. So what we've got right here, this is more or less what you'd think it would be. This is a rose plant. This is a wild rose, probably the prickly rose. Again, it's got these deciduous leaves. You can even see that there's some insect damage on those leaves. If we look across the river, I guess this is almost more of a landscape shot you'd be getting here. Those trees in the distance that haven't leafed out yet, those are trembling aspen. They're called trembling aspen because when the leaves shake in the wind, they kind of like they shimmer back and forth in a kind of a trembling way. Down here, of course, this is Chicken Creek. There was a big storm earlier today. We had a big hailstorm while I was doing that video earlier. It's kind of hard to even hear myself talk. And so the creek is very swollen right now, not only with snowmelt, but also just with the rain having fallen. So it's carrying a lot of sediment down into the Bulkley River. At other times of the year, it's much less water being carried there, and you'd be seeing a lot of, you could even see salmon there seasonally. It's something that is an example of wildlife that comes up the creek here. Looking at a finer scale, at the forest understory, the smaller and smaller scale we get, the more species we start to see. So right here, we've got this kind of moss right here. It's called steppe moss. And then right next to it, a different moss. I think this is called electrified cat's tail moss for kind of obvious reasons. And then we've got twinberry here. We got a fern right here. You can actually like smell the crushed ferns. Some of you know that you can eat ferns. This is an example of a lichen, which is not exactly a plant, not exactly a fungus. It's actually a partnership between a plant and a fungus. And you'll see these hanging from trees. It's called Old Man's Beard, I think, would be this one. So that's another example. Again, the smaller scale you look, the more different kinds of species you're going to find. Here we have some kind of fern. This is a primitive plant called a mare's tail or a horsetail. There used to be forests of these things that were the size of trees millions of years ago that they used to cover much of the earth. Pine cone. Got grasses here. Dandelion. I think that you can see that whatever scale you look at, you're going to start to see different kinds of organisms that will become clear to you. If you're looking at a landscape scale, you're going to start to see the wildlife a bit more likely, maybe birds in the distance. If you're looking at more of a close-up scale, you're going to start to see those individual trees and maybe be able to identify some of the trees, and I can help with that. And then really close up, these smaller organisms that are most of the species in an ecosystem start to become clear. So that's all I want you to know for, that's all I'd like you to know for the subboreal spruce zone. But what I'm going to do next is that we're going to go to a different site to see an example of the interior coastal hemlock zone. Hi again, Science 10. So here we are on the school grounds. Purpose of being here is to show you some of the other zones that you can see from the schoolyard. So of course, being in the school grounds, you can see the subboreal spruce zone. Well, it's what we're in, even though you can't see the trees because they've been cut down, right, through forestry. In the background though, there's two other biogeoclimatic zones that'll be showing up. Let's move this a little bit, and there, better. Okay, the ski hill that you can see over up there, okay, that's in the Engelmann spruce subalpine fir zone. So if you go up there, you're not going to see the same tree species we see down here. You're going to see a lot more, you're going to see a kind of spruce called Engelmann spruce, at least some of them. I'm going to see a lot more fir trees. These trees are, you know them because they have very sharp, triangular tree crowns. They're very regular in their cross section, very sharp, triangular top of the tree. Further in the background there, you can see the top and towards the top of Hudson Bay Mountain. When you're looking at that, there's no trees there, so you can't name it after a dominant tree species. Instead, we call that alpine tundra, and it's got its whole other set of wildlife species that you're going to find there and plant species. I'd be very impressed if any of you decides to do your ecosystem photo tour project by hiking up into the alpine tundra and talking about that for a little bit. That's all I'm going to show you from right here. Hey everyone, so I am now at Twin Falls Recreation Site. This is the first of a couple of clips I'm going to take here. I just wanted to start by showing from the road kind of a cross-section of the forest, like what it looks like when you're in the forest floor, but you can see the trunks in the distance and even the tops of the trees. We're on a steep slope here, so that's going to be possible to see all that, and also hear the creek underneath. In fact, when I take the waterfall video in a little bit, it might even be hard to hear my voice. So I'll show you this, and there's something else I want to show you about the trees, because I'm asking you to identify some trees, and I want to give you some tips. So first of all, you know, whenever I'm here, this place kind of reminds me of home. I come from Vancouver, some of you know that, and this is a lot like the forest looked like back in Vancouver. Really big, tall trees, quiet and rainy. But what I want to show you just now is how to identify some of these common tree species from their bark. Here we go. So this tree right here is subalpine fir. Something you'll notice about it is it's got these little like pock marks in it. Otherwise the bark is very smooth except for these pock marks. Often they go in a kind of a circular arrangement, like with horizontal lines all around the tree, like little knife cuts as if they're into the bark. And here, this one we see it's just little pock marks. A younger tree, you're often going to see needles actually coming right out of the trunk. That's really a distinctive for the subalpine fir. Right here, we've got a spruce tree. For the spruce tree, for its bark, think kind of chunky. It's got heavy, thick flakes that are not quite like the hemlock, which I'll show you in a sec. These are the flakes, kind of look like this. They're going to be around that size. One's for the subboreal, for the hybrid spruce in the valley. The flake's going to be a bit bigger, but it looks like even here at Twin Falls we're getting a few of these spruce, and this is an example. This actually might be an Engelmann spruce rather than a hybrid white spruce. I honestly don't know. Most of the trees that we're seeing around us here are hemlock trees, though. They're the dominant tree of this area, which is why they call this the interior cedar hemlock zone. There's lots of hemlock trees here. How do you know a hemlock tree in profile? From its bark. Well, here's one right here. It's subtly different from the spruce. Whereas the spruce, the chunks of bark were a bit more, I guess, eye-shaped would be one way of describing it. These are more like strips of bark. The other thing for the spruce versus the hemlock is this. All right. So what we've got right here is hemlock leaf. Now watch hemlocks. This is a twig with a hemlock on it. Now watch this right here. Profile, and from below, kind of pale blue. From above, green. That's your typical hemlock. This might even be a hybrid between the coastal and the mountain hemlock because of all the needles coming off the top right here. So there you have hemlock right there versus right here. There's an expression, don't shake hands with a spruce. What that is saying is that the needles of a spruce are a lot sharper. When I'm putting my hand around this, I can really feel the pinpricks from those needles going into my hand. That's not a problem with hemlock. It's very soft, and the individual leaves or needles are arranged more in a flat pattern. So spruce, and you're going to see the spruce. You know, I see a few spruce up here, but mostly you're going to see spruce like where I was before at Chicken Creek. Lots of spruce down there. In fact, really that's the dominant deciduous tree down there. Dominant coniferous tree down there. The ones that drop their leaves, the deciduous trees, there's a whole bunch of other kinds, and I'll maybe go into that later. So those are the leaves of the spruce and of the hemlock. I'll see if I can find some fir as well. All right, nothing showing up for right off the bat. I'll bring those out a bit later. Hi there. So here I am. This is at the waterfall observation site at Twin Falls. So as you can see, aptly named, we've got the two waterfalls in the background that we can see. What's above me is the Catherine Glacier, and this is a very important thing. So I talked to you in this course a little bit about, obviously, the unit about energy. And energy transfer in the biosphere climate is one part of that. Now, climate is something we can consider at a huge scale, like across the province, for example. But there's also something called microclimate, which is a climate at a very small scale. In this case, the scale of a little watershed, the Glacier Gulch watershed. This is an interesting place because it faces north and a little bit east, I guess, and so the sun doesn't shine directly here very often. Also, the sides are very steep, and so I guess that comes into the fact that the sun doesn't shine here often. In addition to that, we have the glacier behind us. The glacier keeps the air cool. Cool air coming off the glacier can sweep down here and keep the conditions here very cool, but also very humid. As the glacier is melting, witness behind us with these waterfalls, this provides a constant source of moisture. There's very high humidity here. You can almost feel the stickiness to the air. As a result of this, we get vegetation that's really a lot like the vegetation you expect to see on the coast. As I said, this kind of reminds me of home, when I mean Vancouver home. What you have here, you have tree species that you really wouldn't expect to see until you're, say, 50 or 60 kilometers further towards the coast from here, especially the western hemlock. We're in the interior cedar hemlock zone, as I showed you from the map. What does that mean? Well, we don't actually have a lot of cedar here, but we have plenty of hemlock. And the hemlock grows to be very large and tall, a lot like you see it on the coast. We're in that interior version of it, which means that, well, it's a little bit different from the coast, but the one thing I do want to show you as well is a little bit about the tree species that live here and how to identify them from a distance. So I've shown you how to identify them from the bark, but I'd also like to show you something for their profiles from a distance. Have a look. So what we've got right here, in the middle of this, really on two sides of the middle of the screen, we got two different tree species. One, middle screen, that's subalpine fir. So subalpine fir, when you see it in cross section, straight as an arrow, and it's got a very sharp, pointy top. You're going to see this here in the interior cedar hemlock zone. You're also going to see it a little bit higher up if you were to go into onto the ski hill to be in the Engelmann spruce subalpine fir zone. In actual practice, the ESSF in this area is almost just the subalpine fir zone and has some hemlock as well. By contrast, let's have a look at, well, really this tree here in the middle now. It's an excellent example of a hemlock tree. This might actually be mountain hemlock, or it could be western hemlock. I'm not in a good position to say from from this distance. But the thing I want you to notice about that is the top. The top of a fir tree goes like this. The top of a spruce tree is pretty similar, although not always as dramatic when it comes to the point. Often the spruce tree is kind of a bit more rounded of a point, but a hemlock tree droops at the top. The wood is weaker because the tree is under pressure to grow so fast. These are trees that grow in places where there's a lot of competition for light. Trees can grow very tall because we're on the coast, there's a constant source of water, but as a result, they all grow tall and compete with each other for light. And so there's always that struggle for light, competing with each other for that limiting resource. So as a result of this, they grow tall at the cost of growing weak wood. Something you'll also see with them is if they don't have a droopy top, they'll often have a flat top, because hemlock trees instead, as they get older especially, often the top of the tree will actually just break off entirely, and so you'll see these hemlock trees from a distance that have a jagged top, and it's flat at the top because the top of the tree isn't there anymore. There's a lot of other stuff going on in the valley floor here. Let's have a look. So you see lots of snow, and we also see a lot of, let's see how this can show up. I can't tell if I'm videoing my keyboard. No, I'm not. Okay, great, that's it. Okay, so obviously here in Glacier Gulch is aptly named. There's a lot of snow here. There's a lot of snow, and also we have a lot of steepness. So as a result, we have a lot of avalanches. Notice that the alder trees here, they kind of face down the slope. It's because there's constantly, over the course of the winter and spring, we've got avalanches coming down here and pushing those stems down the slope. Slide alder, which is what this is also called, or mountain alder, I think, has the ability to spring back after it's been crushed by snow. Not a lot of other trees are so good at that. A lot of other trees that tend to they'll grow in these spots, eventually they get smashed to pieces by the avalanches that come through here every season. So that's an example of the one kind of tree that grows here as well. I'm going to take the camera a little bit further up just now and get some photos of the shrubs that live here and some of the little understory plants. Something you find about here is it's difficult to be a tree and to do well in this environment. There's always snow pushing the trees away. It's actually fairly dark here. So as a result of that, a lot of understory plants, especially mosses and lichens, start to do really well in this environment. So if we look here, look at what we've got. We got this plant right here, which looks like a moss, but isn't. It's actually called a club moss, but it's not a real moss. It's actually a primitive plant, the likes of which used to be in forests covering the entire land base of the world just about. There used to be forests out of these things with the individual club moss plants growing to the height of trees. Today, those are the coal deposits that are such an important fossil fuel resource. Those types of forests disappeared, I think around 150 million years ago, a long time ago, before the dinosaurs. Here we see a close-up. I already showed you a close-up of hemlock. Hey, let's look down here. This here is sphagnum moss. You're not going to find this stuff so much in the valley floor. It flourishes really where there's lots of water, and even if the soil is very poor quality. Some shrubs. What you see right here, this is something you're going to find along Chicken Creek. This is red elderberry. When these leaves get bigger and the flowers flush out, you'll see bunches of white flowers. That's typical of red elderberry, as well as the opposite leaf pattern that you can see on these stems. That's more Bio 11 talk for you. This, maybe some of you already know what it is. is Devil's Club. You don't shake the hand of a spruce, but you definitely don't shake the hand of a Devil's Club. It would be excruciating because they have such tiny spines and so many of them. All right. You know what? I'm not seeing a lot of new stuff up here, but it's that talk of the microclimate that is what I really wanted you to know, and that we're in the interior cedar hemlock zone, which would then grade gradually into the exterior Engelmann spruce scrub alpine fir zone. And then going higher up, you're getting to rock and ice. Ice is not a biogeoclimatic zone because there's no trees on it and nothing growing on it at all. And then we have alpine tundra, which is a biogeoclimatic zone, but is typified that it doesn't have any trees growing on it either because it's just too high altitude for trees to grow. Those are all visible from Smithers, and here we're very close to them. If any of you have ever done the hike to Crater Lake, then you've been on the alpine tundra zone, and you know how in July and August it's a really pretty place to go because there's lots of flowers. So anyways, that's all I want you to see about the Twin Falls site, and I'm happy to answer questions you might have about plant identification and shrub ID. I've got lots of resources at the school. I can help you out with that, and I hope to talk to you soon. Bye for now.